So today, yeah, as Robert just mentioned, I'd like to present on PM2.5 emissions from natural gas-fired plants. And this is based on some results from a larger collaborative study that we carried out looking at fine particulate emissions. And that was undertaken by Uniper on behalf of DEFRA and the United Kingdom Environment Agency. Some of the co-authors are down there. Right. So, the background. For natural gas-fired plants, so natural gas is obviously an ash-free fuel. Usually it's filtered prior to utilization, so there's no filterable particulate matter in the flue gas, or it's assumed that there isn't any. And obviously efficient combustion on gas plant means that there's no additional filterable particulate matter generated. But there's very little measurement data available to demonstrate the actual emission levels. And this is because, obviously, SRMs are based on gravimetric analysis. The limit of detection is generally between 0.1 and 1 milligrams per meter cubed at best. Also, CEMs are not appropriate for the expected particulate matter levels. And how do you calibrate those CEMs anyway if your SRMs are not appropriate? So the gas-fired plant are just expected to pass through the ambient particulate matter. And additionally to this, obviously gas turbines actually filter the combustion air, so potentially could be a negative emission. Dust monitoring is generally not required, and mass emissions reporting is normally based on emission factors. And in the UK, the power sector uses an emission factor of 0. So the UK government-funded project had a number of objectives, and obviously Uniper were charged to carry out this testing for them. So the idea was to characterize the PM2.5 emissions using advanced instrumentation. And initially that was at the 3 energy from waste plants. And as I said, this has been reported last year. Oh, sorry, whenever the previous CEM conference in 2023. But then following on from these tests on these 3 sites, there was then included a natural gas-fired boiler and a gas turbine. And for this test, the idea was to focus on these 0 emissions. And obviously, DEFRA, their idea is they want to know how low is low. They want to know, to do this, we want to obtain hourly mass concentration data and compare that with a CEMS response. Also, can you calibrate these CEMS if you get this lower data? So can you get a qual 2? And obviously the energy from waste sites anyway were fitted with light scattering CEMS and did have emission limit values of 5 milligrams. They wanted to get some actual PM2.5 and PM10 data and confirm that these were very low. And they wanted to, if possible, support this with gravimetric measurements, so using the SRM. And from that, they wanted to determine the particle size distributions from these plants. So they wanted to make sure that the reporting assumptions were correct. And that is, at the moment, that the PM2.5 makes up all the matter. It's equivalent to the PM10, and it's equivalent to the total particulate matter emitted. So the field trials then. So what did we actually do? Our primary measurement tool was a heated version of the Ducati LP+, and this heating element allowed us to operate it on stat gas with no sample dilution. It uses a 14-stage aerodynamic particulate matter separation, and the particle counting is by electrical discharge. And you see on the photo there, that's enclosed in the heated, here in the heater jacket. So then you can collect on each stage, you can either use sintered plates or greased aluminium foils, and this is to where you collect the particles, but also count them essentially. You can see on the photo there, on the first photo, that's actually a greased foil, and this is not from these sites, but you can see the actual particulate material collected there. And then we had a secondary measurement tool. This was actually a Pallas VDAS 200, which is an ambient air quality instrument. So this uses optical light scattering of single particles. Obviously, it's for ambient sampling. So for this testing, we had to incorporate a dilution system and to make sure we got a dried sample. All the tests were carried out isokinetic sampling, but we had a fixed nozzle at a single point in the stack. So a quick summary of what we got from the energy from waste plants. Sorry, I'm a bit behind here. So the data we obtained was from the 2 parallel test instruments I just mentioned there, but that was with the dilution on the VDAS, approximately 10 to 1. What we found, though, that the SRM, as expected, there was insufficient mass collected. So it's less than limit detection, and there's no comparison possible between the standard reference method and the advanced measurement techniques. Also, the CEMs basically were not responding. The readings were 0 or close to 0. There weren't the qual 2s applied to them, and we weren't able to